Okay, welcome to MathForKids50. Why do I always cough at the beginning of this? I don't really know. Okay, so this morning we were studying some fractions and we came across a really neat series of fractions. We thought we'd talk about it. Sound like fun? Okay, so the series was this. It was 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus 1 over 5 times, plus 1 over 5 times 6,
etc., etc., etc.
So why don't we talk about this and see what happens sometimes when you have these long series that you're taking a look at. It's helpful to look at just kind of the beginning and see what it equals. So what if we just looked at only the first term? What does that equal?
It's 1/2.
1/2, okay. Boy, I should have thought about where am I writing stuff here. Right, the first term's just 1/2. Maybe I'll make a little chart over here. Terms.
Make sure that's on camera.
First 1, first 2, first 3. Think that's on camera? See, why don't you take a look and see if this first 3 is on camera. See it?
I'm going to flip it.
Oh, you're going to flip it around? Okay. Oh, not even close. Oh, is it? Maybe. Okay.
You should move up.
I'll move it over to the side over here. Okay. So the first term is 1/2. That's fine. What if we look at the first 2 terms? 1/2 plus 1 over 2 times 3. Yeesh.
That's 1/2 plus a 6.
Okay, what does that equal? Oh, make sure you stand to the side so the camera can see 1/2. Tell you what, let's switch sides.
It's the only way I can write it.
Okay, let's switch sides so you don't have to write it. That's funny. Okay. 1/2 plus a 6. Okay, I'll write it for you real quick. 1/2 plus 1, 6. And what does 1/2 plus a 6 equal? How do you do that?
Well, you get the denominators the same. We talked about this in our previous video.
Yeah, we did. Okay, so what is 1/2 plus a 6?
This becomes 6 twelfths plus 2 twelfths.
Okay. 8 twelfths. Okay.
And that can be simplified.
It can? Okay. What does it simplify to be?
There's 2 times 4 over 2 times 6.
Okay, so it's 4/6.
Can still be simplified.
Yeah, scoot over just a little more. Okay. 4/6 is the same as
2 over 2 times 3.
Great. Okay. So what is
2/3.
Okay, great. So the first 2 terms multiply out to be 2/3. That's kind of neat. Okay, let's look at the first 3 terms. Okay, so 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. What does this equal?
Well, we can do something here.
Okay, what can we do?
We know that this equals, this is 2/3. 2
Okay. Because we already added up the first 2 terms, so we know they add up to 2/3. So this is 2/3 plus
times
what?
Plus,
yeah.
1/12.
Okay, very good. So how do you do 2/3 plus a 12th?
Multiply this guy by 4 over 4 and this guy by nothing.
Wow, how does that work? I thought you had to multiply by 12 over 12 and 3 over 3.
Well, 3 goes into 12.
Oh, I see.
So this becomes 8 twelfths plus 1 twelfth, 9 twelfths.
Okay, 9 twelfths. Okay.
And that can be simplified as?
Well, simplify it down here.
Okay.
What does 9 twelfths equal? Stay where you're standing, but what does 9 twelfths equal?
This equals
Scoot over a little.
3 times 3 over 3 times 4. 3/4.
3/4, okay. Is this on camera? Hopefully. 3/4.
It is.
So the first three terms equal 3/4. So so far we get a sequence of 1/2, 2/3, 3/4. You want to do one more to see if you can see the pattern?
I see the pattern here.
Oh, you see the pattern, okay. What do you get?
Because the bottom, to make the next term, the bottom of the previous one goes to the top, and the next number comes in.
Okay, so you get a 1/2.
So, and then the 3 comes in.
Okay, what would be the next one then? 1/2, 2/3, 3/4.
4/5.
4/5, okay. Let's see if that's the case.
It looks like that this
Okay.
is just this over that.
Okay, so let's see. When we add up to here, well, we know from your trick that you did last time that when we add up to the first 3 terms, we know we get 3/4. This is 3/4 plus 1/20.
So here, go 5/5.
Right, just multiply by 5/5.
15/20 plus 1/20.
Okay, what does that equal?
16/20, so that can be simplified.
Okay, and what can that be simplified to be?
I'll write it down here.
Let's get over.
So 4 times 4 over 4 times 5 over 4/5.
Okay, awesome. So it looks like we found kind of a neat pattern. And what can we say about these numbers? 1/2, 2/3, 3/4, 4/5. Can we say anything about them? That's interesting.
Well, these numbers are above 2/3. They're all below 1. They keep getting closer and closer and closer and closer and closer to 1, but they never
They
get
keep
there.
getting closer and closer and closer to 1. Okay, so it's interesting. So if we look at where these are in a number line, so here's 0, here's 1. Oops. Here's 0, there's 0. I mean, here's 0, there's 1.
These 0 does do this.
Okay, here's a 1/2. Then we go a little bit further over and we get to 2/3, maybe here. We go a little bit further over, we get to 3/4. We go a little bit further over, the next one was 4/5.
And then we're going to get
We
5.
seem like we keep getting closer to 1. I wonder if we're ever going to get bigger than 1.
And we're going
Why not?
to get closer and closer and closer.
Why do you think we won't ever get bigger than 1?
Because the numerator is always going to be smaller than the denominator. 'Cause the denominator is 1 more than the numerator.
Ah, interesting. The numerator is always just a little bit smaller than the denominator. In fact, it's always 1 smaller than the denominator. Okay, so we could guess that if we kept going with this, so let me come over here and write for a second. If we kept, sorry, bash bang. If we, step on your foot. Sorry about that. If we went all the way up to, and the last term was like, oh, I don't know, 99 times 100. What would if we added?
No, it's just someone's upstairs.
Someone's upstairs. Okay. So when we got to 4/5, the last term was 1/4 times 5, we got 4/5. What do you think if we added all the way up to 1 over plus 99 times 100, we would end up with?
Probably 99 100ths.
99 over 100. Okay.
That would maybe about here.
Well, it's probably really close to 1. That's probably getting super close. Maybe right over there. So it's interesting. So we have all these terms and we have all these positive numbers that we add together, but we never quite get to 1.
Telescoping.
Okay, so let me tell you about telescoping. Come back over to the other side. If you study this a little bit more, and this is a little advanced, so that's
This is just an
okay.
introduction to this.
We can write this as 1 minus 1/2. That's what 1 over 1 times 2 equals. And we can sort of see that, right? 1 minus 1/2 is 1/2, and that's also 1/2. 1 over 2 times 3 is the same as 1/2 minus 1/3. So we have to figure out, why is 1/6 equal to 1/2 minus 1/3? And the answer is, when we get a common denominator, and I'm going quickly on this because this is a little advanced, so you don't have to understand this completely now. You get a common denominator is 6, right?
Yes.
So you get 3/6 minus 2/6, which is 1/6. And over here you get 1/3 minus 1/4 plus 1/4 minus 1/5, and it keeps going like that.
etc., etc., etc.
etc., etc. And because of the associative property, we can move the parentheses. Okay? So instead of putting the parentheses like this, like I did, we're going to move the parentheses.
Like?
Wait a minute. We're going to put the parentheses like this. Okay, and we get 1 and then minus a half plus a half. What's that?
All these cancel.
Whoa, careful. No matter, so wherever you decide to stop, like here when we stopped at 1 over 4 times 5, we end up with 1 and then 0, 0, 0, minus 1/5. And if we decide to stop at 1 over 99 over 100, we would just have minus 1/100th would be the only thing left. And if we decided to stop at 1,000,000, we would have 1 minus 1 over 1,000,000. Because that minus 1 over 1,000,000 would be the only thing left.
If we stopped at Googleplex.
If we stopped at Googleplex, it would be 1 minus 1 over Googleplex.
There's not enough
And this
answers
is called a telescoping series because it starts out really long, like a telescope. Yeah, have you ever seen a telescope that you hold in your hand that you pull out like that?
Like a spyglass at this.
Yeah, like a spyglass. Or sometimes they have bendy straws that you can, pull out really long and then shrink them up. This is called a telescoping series because
I love 3D shapes.
it looks really long, but then you just smash it all together, whoosh, and it goes to just 2 things. So this is a really neat series, and it's an amazing fact.
This equals that.
Did you ever think you could have all these things added up together and you would still never get to 1? Can you believe that? And by the way, let me just take 1 extra minute here and tell you that there's lots of neat
Properties.
little series like this. For example, this series, 1 plus a half plus a fourth plus an eighth plus 1/16.
Plus a 32nd.
Okay, when you look at the 1 over powers of 2, this adds up. This gets closer and closer to 2, but it never gets to 2. And this series, 1/4 plus 1/9 plus 1/16, you're never going to believe this one. What comes next? What's the square after 16? I can't remember.
Squared.
2 squared, 3 squared, 4 squared.
5 squared.
Which is what?
25.
This one 25th.
Ooh.
Plus, what would be the next one?
Etc.
What would be the next one after 125th?
36.
136th, okay? This, you're never going to believe what this adds up to. Or gets closer and closer to, but never quite gets to. You know what?
What?
Pi squared over 6.
Wow.
Can you believe that? So there's lots and lots of really neat series. And when you get a little older, we'll study about these and how you can understand these. But this is some really neat stuff that you can do with fractions. That's why studying fractions is really fun. Yeah?
Yeah.
All right. Good job, Mary.